Hi, my name is Alexandria Harold. I've played the oboe for about 3 to 4 years now. I used to play in my school's concert band, but dropped the class because I didn't have time this year. My oboe is made from wood. I personally like it, but other people might prefer a plastic one, which oboes can be made from. Now, since science is the key to what our world is, then we should work hard to learn about it so that we can evolve and find out what evolves with us. So, today I will be covering the science behind oboes and breaking it down into smaller sections. I'm covering what an oboe is, the history of the oboe, and then what makes the oboe create its sound. Let's begin with my first point, which is what an oboe is. So, an oboe has a reed, and the reed is its characteristics, its personality, it's what helps create most of the sound. Oboe reeds have been notorious for being unpredictable. A finished reed that starts its concert career may emit a few perfect notes or bars of music, but then may abruptly fail by whining in very unsoundly sounds as it continues to die. Another reed may yield a pure and beautiful note for a symphony, or even, but rarely even happens, an entire season. This came from Brown's article, The Shaping of Oboe Reeds. Maybe it is rocket science. Reeds are made from cane, which would be this part. This part's the string, then there's a wax cover over it to hold the string down, and then you have the cork, and it's all put on a metal piece. Reeds are made from cane. Cane comes from and is also grown on the east coast of Spain or the south of France. Cane is usually dried and aged for years in the same areas that they were grown in. They are then carefully fashioned into a reed-shaped kind of. It'll have the arch that the reed will need, but it'll be in one length. And what happens is, since it's the key part to get the sounds on the oboe, then you have to have somebody that can make a really good one. And this is from the Oboe, one of my sources. Depending on the way the reed is made, it will tell you if it is a good quality or if it'll need a little bit of refinement from you, that way it fits you. They can be shaped to fit different people and show personality to the instrument when it's being played. It's really important because everybody's different. For the oboe body, which I have here, this is mine. The oboe is a soprano range double reed wooden instrument with a length of about 62 centimeters for the average one. Its wooden tube is distinguished by a concave board expanding at the end into a flared bell. The modern oboe range extends from the B flat below middle C, which is, if you have known music, you'll have the bars, which will have 5 lines. It'll go about 3 lines below, and then to the A, nearly 3 octaves higher. So this is 1 line, 2, 3. This is how far it goes up. And this is also from the oboe. The melodic instrument capable of its general expressive passages. The instrument is yet said to take a large air pressure to play, although the range of pressure between the softest and lowest sounds is said to be larger than the woodwinds for most of them. Even the clarinets and the saxophones and all of them, they don't have as much pressure, even though they think they do. And your pressure is what controls the reed and is necessary to make the embouchure adjustments to play each note in tune. This is also from the article The Oboe. Now that we've covered my first topic, what an oboe really is, let's move on to the history of the oboe. So how the oboes used to be made, they were traditionally made from African wood, also called grendilin. The instrument is made in three parts. You have the top joint, which has 10 or 11 holes, depending on which one it is. Some of them are specially made to have a couple more than 11. Some are only meant to have 10. I have not bothered to count any of these. And most of which are manipulated by the player's left hand. The bottom joint, which has also 10 holes, but it can have more, for most of which the player uses the right hand. The bell section has 2 holes. Mine only has 1, but some have another one for more playing. And it still is only played by the right hand, but it connects here by the joint and is played from here with the right hand. They're made exceptionally from craftsmanship, which still happens today, but it does change. The classical period brought on several more changes to the oboe. A narrow body called the bore and more keys gives the instrument a much wider range. From this earlier form came the modern oboe, which is the one that I have today. And it's usually made from the same wood that they used to make, but they can be made from other woods, from the rainforest. Student models are usually made of plastic. Mine is not. I don't know why, it's what my mother had. And they have a higher range of 2.5 octaves higher from the low B into a higher A, which uses a key system called the full controversy, which has 45 pieces, most commonly made from silver. This came from Instruments in Depth. My second point to this would be, well, what else can we learn? Oboe is also considered to be an orchestral debut in France, an orchestra instrument in case. Makes no sense sometimes. So it's an orchestra instrument as well, because what happens is the oboe will tune the instruments for the strings with the oboe's A, which should match its pitch, but it doesn't always. So now that we have covered the history of the oboe, let's move on to the science of an oboe, which would be what makes the oboe sound. So a guy once did a science test with a straw and made the shape of an oboe reed. Although instead of having this shape, he cut it to where it was a triangle, and it behaves like a reed on the woodwind instrument, as for oboes and saxophones. And when you blow through the straw between the two reeds, it moves very fast. The only way for air to speed up is to move from an area with higher pressure to one with lower pressure. So the pressure between the reeds must be lower than in your mouth. This means that the high pressure air outside the reed will push them together, closing them off. This is from Straw Oboe, which is another article that I looked at. The reed starts and stops the flow of air very sharply, which produces a mixture of huge number of different pitches of sound. The sound is then fed into the straw and travels up and down the straw, reflecting off both ends, a bit like water sloshing up and down a bath. Some pitches, such as the one with the wavelengths the same as the length of the tube, will strengthen by this process, also from straw oboes. Your embouchure is also one key to it, because if your embouchure is too weak, you're not going to be able to play. But if it's too hard, then you're going to break your reed quite quickly, and then you'll have to go up to the next reed. They're made differently for people, as I said. And you'll probably start out with a weak reed, but as you continue to play, you'll strengthen your embouchure. And when you have a strengthened embouchure, you can usually play pretty consistent notes all the time. So, now that we've covered all my points, let's conclude. Since today I've covered what an oboe is, the history of the oboe, and what makes the oboe create its sound, as for my science, then what do we think the oboe science is? Well, the science is probably, as I had said, your embouchure, which will help create the sounds. If your embouchure is too weak, it's not going to work. And we've learned about the history. It's come quite a ways from the classical period all the way back to Africans creating this. And then the reed and the oboe itself. The oboe is a soprano range instrument, and it has its double reed made from cane, which takes years to process. The oboe is one of the most remarkable instruments out there to play to me. So maybe one day you'll find one and consider trying it, or even look into the science behind it, and I hope you do, because that would be